Hello students, let us talk about series and parallel combination of resistances. First we talk about series combination. Series combination में किसी भी resistor के through current same रहता है. We get same current through all the resistances in series. So same current through all resistors. In series. So in series combination we get same current through all the resistors. Actually this is the method to identify whether a given set of resistors is in series combination or not in a complicated circuit. So suppose we have been given a set of resistors like this. Its resistance is R1, its resistance is R2 and its resistance is R3. Now we have to identify whether it is in series or not. For that we will check whether same current is flowing through all these resistors or not. And to do so we will connect the ends A and B across the terminals of a battery. मान लीजिए कि इस बैटरी से आई करंट फ्लो कर रहा है, बैटरी से आई करंट निकल रहा है, तो आई करंट R1 में भी जाएगा, R2 में भी जाएगा और R3 में जाएगा, क्योंकि करंट विल नॉट बी डिवाइडेड एनीवेयर हियर. सो वी current through all the resistors will be same and we will say that this is a series combination of resistance R1, R2 and R3. Now let's say potential difference across R1 is V1 and potential difference across R2 is V2 and potential difference across R3 is V3. So total potential difference will be V. V will be equals to V1 plus V2 plus V3. From Ohm's law, V1 will be IR1. V1 equals to IR1 from Ohm's law. Similarly, V2 equals to IR2 again from Ohm's law. And similarly, V3 will be IR3 from Ohm's law. So putting all these values V1, V2 and V3 in this equation, we get V equals to IR1 plus IR2 plus IR3. Take I common, so we get V equals to I R1 plus R2 plus R3. Now we want to find out the equivalent resistance of these three resistances. यहाँ पर equivalent resistance कहने का ये मतलब है कि अगर इन तीनों resistors को replace कर दिया जाए एक single resistor से, let's say its resistance is R equivalent और इस रेजिस्टर को भी अगर सेम पोटेंशियल डिफरेंस V के अक्रॉस कनेक्ट कर दिया जाए, अगर ये रेजिस्टर भी ड्रॉ कर रहा है सेम करंट I जितना कि इस केस में ड्रॉ किया गया था, then we will say that this is the equivalent resistance of these three resistances. So here we see that under same condition of potential difference, this R equivalent is drawing the same current I as is drawn by three resistors together. So R equivalent is the equivalent resistance of these three combination of series resistances. Now let us apply Ohm's law here. By applying Ohm's law, we can write that V equals to I R equivalent. Let us call it equation second and let us call it equation 1. Now equating equation 1 and 2, we get I R1 plus R2 plus R3 equals to I R equivalent. So from here we get R equivalent equals to R1 plus R2 plus R3. So in series combination of resistors, equivalent resistance will be simply the sum of all the individual resistances. So now let's see the parallel combination of resistors. Let's talk about parallel combination of resistors now. In parallel combination of resistors, we get same potential difference across all the resistors. So in parallel combination, we have same potential difference across all the resistors. Same potential difference across all resistors in parallel. Actually, this is a method to identify the parallel combination of resistors. So suppose we have a set of resistors like this. Suppose its resistance is R1 and its resistance is R2 and its resistance is R3. Now we have to identify whether it is in parallel combination or not. To do so, let us connect it across the terminals of a battery. This is point A and this is point B. So across point A and B, we have to find out if it is in parallel or not. To do so, let us connect it across the terminals of a battery. Battery having potential difference V. We see that potential difference across all the resistors are same. So we can say here that this is a combination of parallel combination. Potential difference across R1 is also V, R2 is also V, and potential difference across R3 is also V. What about the current? Are current same in all the resistors? Let's say current I is flowing through battery V. लेकिन ये करंट यहाँ पर अलग अलग ब्रांच में डिवाइड हो रहा है, जिसके कारण मान लीजिए कि इस ब्रांच से I1 करंट फ्लो हो रहा था एंड इस ब्रांच से I2 करंट फ्लो हो रहा है एंड फ्रॉम थ्रू दिस ब्रांच I3 करंट इज फ्लोइंग. We can find out the values of I1, I2 and I3 by applying Ohm's law, because we know that the potential difference across R1 is V. So current will be, from Ohm's law we can write V equals to I1 R1. So I1 equals to V by R1. Similarly, in the same manner, I2 and I3 can be found out. I2 will be V upon R2 and I3 will be V upon R3. Now total current I equals to I1 plus I2 plus I3. Putting values of I1, I2 and I3 in this equation, we get I equals to V upon R1 plus V upon R2 plus V upon R3. Now let us find out the equivalent resistance of these three resistors. यहाँ पर इक्विवेलेंट रेजिस्टेंस कहने का ये मतलब है कि इन तीनों रेजिस्टर को अगर रिप्लेस कर दिया जाए एक सिंगल रेजिस्टर से, जिसका कि आर इक्विवेलेंट रेजिस्टेंस है आर इक्विवेलेंट, और इसको अंडर सिमिलर पोटेंशियल डिफरेंस से कनेक्ट कर दिया जाए, सेम पोटेंशियल डिफरेंस से इसको अगर कनेक्ट कर दिया जाए V से, and if this resistor is drawing the same current I as is drawn by the all three resistors together, then we will say that this is the equivalent resistor of these three resistors, and this R equivalent is the equivalent resistance of these three resistances. Now let us apply Ohm's law here. From Ohm's law we can write V equals to I R equivalent. So I equals to V by R equivalent. Let us call it equation 2 and let us call it equation 1. Equating equation 1 and 2, we get V by R equivalent equals to V by R1 plus V by R2 plus V by R3. From here we get 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. So in parallel combination, equivalent resistance is related by this equation. 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3.